speaker is Anna Huang. She's a research scientist at Google Brain working on the Magenta project, and she's also an adjunct professor at the Université de Montréal. Her research focuses on designing generative models and interfaces to support music making and more generally the creative process. Her work is at the intersection of machine learning, human-computer interaction, and music. She's the creator of the Google model Coconut, which powered Google's first AI doodle, the Bark Doodle, which in 2 days harmonized 55 million melodies from users around the world. And she's a judge and organizer for the AI Song Contest and also a guest editor for Tismir. Thank you very much for presenting today, Anna Huang.
Thank you, Rosie, for the kind introduction. I'm going to share my screen. Oops. Okay. Thank you, everyone, for coming. I know this is the end of the last day of the conference, so everybody must be a little exhausted. So thank you for making the extra effort to come. Yeah, today I'm going to kind of zoom in and focus on Music Transformer and talk about what are the ways we have tried to tune the model in terms of making it more adaptive, and also how musicians are trying to tune them to be able to use them in their creative practice. So this is NLP for Music and Audio workshop. I won't be talking as much about kind of language, text as language, but I'll be thinking about music as a form of language, and in particular as a form of this emotional communication that we all feel. And I'll show how developments in both improving our generated models and also thinking about steering interface to give users more agency. Both of these can help us move towards this goal of really enabling music as a form of communication. So first, I wanted to kind of show this map of a more user-centric kind of view of generative modeling. So in traditional generative modeling, we usually think about the data, music as data, and then we try to model the characteristics, the patterns in that data. And that gives us a generative model that has some kind of interface. For example, like language models is often like an autoregressive interface. You give it the beginning and then it does continuations. But a lot of times users want more than that. They want more control and they want to steer these models in different ways. So in terms of designing these generative models, we can also take an interaction-driven approach where we first think about the user and what they want to do, and then formulate the task in terms of inputs and outputs that way, and then be able to have a model where users can kind of use it to achieve their goals. So today I'm going to kind of go both bottom up and top down. So I'll first talk about Music Transformer. I'll give a short intro of it just to kind of get everybody on the same page. And then I'll show how some musicians and some teams use this model in the AI Song Contest towards their creative vision. And then I'll talk about some, from the AI Song Contest, we saw some challenges in terms of how people found these models actually pretty difficult to use. So we then thought about ways to give people more control. So one way we've been approaching it is to think about music not just as kind of this linear process, but more as a tree-based kind of exploration process. Especially when you're interacting with a generated model, there's many possible worlds you could be in, and how do you explore that? And at the end, I'll talk about this work where it tries to situate why users might be steering in different ways. So if you're just kind of steering in a forest according to things that you prefer or not, your preference might be is probably guided by some higher level goal of wanting to communicate something to who you want to share this music with, or kind of express yourself. So I'll talk about this last part in terms of how to use communication and how effective the communication is as actually this evaluation framework to evaluate if these tools and models are actually helpful. Okay, so I'll first start with music transformer. So one subtle aspect is where, so definitely transformers are a general class of models, so you can feed in any kinds of sequences. In particular, we wanted to focus on sequences where we can not only model the music, but also the performance, the performer's interpretation and expression of the music, because we wanted it to really sound good so that somebody wants to engage with it and have this iteration. So here is just a quick visualization of, on the top, it's just a piano roll of the notes of the music, but on the bottom, the colors are showing how the expression of the pianist. So you see there's a wide range of ways that the pianist is shaping the music. And also in terms of the timing of things, it's less on a grid. So the data set we then decided to train the model on is from this piano competition where a lot of pianists competing in this contest, they played on the Yamaha disc clavier pianos. So we were actually the contest themselves recorded all the music, so it captured all the expressive timings and the expressive velocities of the pianist. So before transformers, the RNNs were kind of the go-to method for modeling this. So there was prior work that tackled this problem. And in particular, in terms of thinking music as a language or as a sequence that we're trying to model, they serialized all the microtiming and velocity actually also into the vocabulary as an event. So here you have kind of an event sequence where you turn on and off notes and at the same time tell kind of like a MIDI protocol, very similar. And you say how loud the note is when you turn it on. And then you have a global clock that you can advance that allows you to capture polyphony. So the excitement with music, with transformers is that it can really capture those longer term structure to get more coherence, so that you actually feel like there's some trajectory going on as opposed to kind of bouncing around. So here I'll show you two samples to illustrate that. So first we fed it like a short iconic motif that many of you recognize. Oops, I'll play that again. This is the RNN LSTM's continuation. Oops. So you hear it going a couple of places. Initially, it's very, very coherent, but then it starts kind of wandering. And this is music transformer. So just visually looking at it, you see it's really following a more predictable trajectory, at the same time really moving the harmony forward. So so that was given a prime, the model generating continuations, and what you see here is unconditioned generation from the model. And we wanted to understand why was it able to really keep this coherence. So we kind of looked under the hood, and what we're visualizing here is the last layer, how the attention looks like. And I've manually kind of highlighted the pieces where the motif kind of comes back. So kind of these broken lines are the motifs. So you really see the attention kind of not just attending to things that happened recently, but really jumping to places where the content is similar. So this really allows it to bring back themes that were introduced before, and then move away and then come back again. So I'll show you kind of an animation of this. So this is the model generating forward, and you see how it's looking back to kind of inform its prediction going forward. So after seeing it was really able to get a lot of structure, we were thinking, can we start from audio? But audio is much longer and the structure is much more low level. So, but the nice thing about audio is that we will be able to transcribe how somebody actually played it and didn't have to rely on symbolic data that was captured through this special way. Like it was this special contest that had this clavier and setup that we were able to have the initial data set. So what we did was we took kind of this factorized approach, kind of putting 3 existing models together. So first we transcribed the audio into MIDI-like symbolic form. So basically and then convert it to the kinds of vocabulary that music transformer takes. So then we can train a generated model just on the symbolic data. So just like what we did before. And then given, as the model generates a new piece, we use WaveNet-like models to condition on the MIDI and synthesize the audio. So with that process, this is one of the samples. So you hear a little bit of an artifact at some points because it's synthesized with the WaveNet. And this allowed us to transcribe, really scale up and transcribe a bunch more piano playing from YouTube. A lot of this music that we transcribe is focused on kind of classical music and music kind of people maybe improvised and put on YouTube for everybody to share. So with that, we also created a collab with a pre-trained model so that people can play with it. So later on, when in the AI song contest, when people use this model, this is the collab is kind of the interface that they had to interact with kind of this instrument. Okay, so now I'll switch to kind of talking about how users, musicians approach kind of thinking about how AI fits into the creative process. So in particular, me and a bunch of folks, we have been organizing the AI song contest. And we really think about it as kind of this community that we're building to really try to accelerate collaboration between artists and scientists so that scientists understand more the needs that musicians have, and also musicians have a chance to really work with these models, understand their strengths and limitations, and be able to use them as part of their kind of bag of tools. So this year, we were very lucky to have Imogen Heath as one of our judges. So she, during the award ceremony, announced the winners. So this contest was also covered by the New York Times and gathered a lot of interest with among kind of a broader audience. So I'm going to talk about 2 entries from this contest. And the first one, it's kind of they use the model in a way of an Easter egg, so in a very small way. The next piece, it was more of a kind of crucial driver towards composing the piece. So this first one I'm going to talk about is actually the winning entry of the AI song contest. So they used a variety of approaches combined to make this piece. And today I'm just going to talk about a small piece of it, but I just wanted to kind of show there's a lot going on. And kind of going in, they had this strong vision of what they wanted to create. And a part of the inspiration comes from Daisy Bell, which is one of like the first pieces that was sung by a computer. So they kind of wanted to pay tribute to that kind of historical moment and be able to think about this kind of strong juxtaposition between like humans and machines. So I'll let you hear a little bit of the beginning of the piece, and then I'll go into how they did this Easter egg thing. Oops, it seems like my playbacks want to do a take two. I wanna be untamed up there in the clouds, sending saints to those across the sky. So it starts out being a very kind of approachable pop song. Later on, it really builds a lot and like shifts the perception. So I really recommend you to listen to it. So this part that I'm gonna fast forward to is actually the ending of the piece. So they were trying to figure out how to end. Like ending is always hard. So the pianist, the producer, he's not a pianist, but given the material that they had so far, they had this chord progression. So they thought, okay, why don't I play this chord progression and feed it into the model and see what the model generates and see if we can take something from it. So here you'll first hear the producer playing. So he's not a pianist, so you can hear the playing is kind of trying to kind of get the chords out. And then the model actually is sensitive to the playing, so it gets a little trickier for the model to listen to them. So the model kind of picked up this general mood and also that rhythm of like short, long, but then it starts trying to want to do something else. It wants to pick up pace a little bit more. So actually what they ended up taking was this very ending that they otherwise wouldn't have kind of imagined themselves, and especially that kind of low little turn. So I'll fast forward you to the ending. Do the people really wanna hang around? Okay. Now that you've heard the beginning and the ending, I recommend you to listen to the middle and see if that's what you could have predicted. Okay, so next entry is from Bob Sturm and collaborators. So Bob has been building these models and jamming with these models and kind of engaging with the folk community by working with this model called Folkarnen. So when he entered this competition, he thought, oh, like, why don't I try to combine these different models and see what happens. So in particular, he has his model generate a melody and then gets the music transformer to generate an accompaniment. So there's a version of music transformer that we worked on where it's melody conditioned. So that's one way for the users to interact with the model. Sadly, kind of during the process of writing the song, his puppy got into this really bad accident. So this piece is actually a lament for the tragedy. So yeah, let's hear some of it. Okay, I didn't realize when I moved it. Okay.
Och fort där vid vägens kant var den sista gången vi sågs. Vad ska vi nu göra? Vår värld är i sig lik. Vårt barn, vår ängel borta är. Vi minns dig så som igår.
I forgot to mention the song is in Swedish because that's where Bob is currently in, and he collaborated with musicians there. So Bob says getting the model to harmonize what he had could work well, but it takes some experimenting to get the right kind of output, as you might expect. So some hacks he would do is to make the tempo really slow or really fast to kind of get the right kind of accompaniment he wanted. And he also realized he, instead of like starting the music where he wants it to start, he would prepend it with some material to kind of get it in the right rhythm. So the whole process is interesting, but like both of us felt like it's a bit of a, like it's a roll of a dice, and we would wish that there's kind of a more steerable process. So with that, I'm going to go into some of our early kind of preliminary attempts to try to address this. So in particular, these models really kind of have their own trajectories that they generate on, and we really want to be able to steer it our way. So this is one approach of thinking about this interaction process as more of a tree-based. So imagine you're kind of walking in this forest. And there's many different kind of directions you could explore. And I'm just listening to like the beginning of paths. So this one I felt was promising, so I went into and listened to a little bit more. I wanted to keep exploring as opposed to exploiting what I've heard. Okay, that's the last one, my last chance. So I'm just gonna go in and see. Actually, I'm gonna sample a path through this tree and see what it sounds like roughly. Okay, that sounds okay, but I feel like I can make it more interesting and more intentional. Yeah, I like that turn. It's a little bit fast, but I'll go with that. That sounds like a pretty nice continuation. Okay, I'm really happy that that one sounds like an ending. So this is the whole thing. So I hope you agree my curated version was better than just the sample in the beginning. So I think allowing people to even do these simple kinds of steering can potentially be really, really powerful. Whoops. Okay, cool. So in that interaction, you probably was thinking, oh, like, how do I know which branch to go to? It's pretty random. There's still a lot of randomness, and I don't have control over where I want to go if I kind of have some idea in mind. So we have some preliminary work where we try to kind of just tune a music transformer to take some controls. For example, if we wanted block chords going forward, we can fit some of the bias, like just do this lightweight kind of bias tuning by tuning just as the name says, just the biases of the model, and be able to have a version of the model where you can say like, yeah, block chords. So I'll show you kind of a quick example of it. So imagine like you're kind of on one of the branches and you're going forward and you want it block chords. So first you'll hear kind of the beginning, which is what you have right now, and then it's gonna kind of switch into okay, and this next one. So the model really wanted to optimize for like more block chords because the function that was kind of the heuristic for measuring block chords was literally like how many of these simultaneous onsets. So it kind of went into this a little bit failure mode of like just trying to put in a lot of repeated notes, but it still sounded more or less natural in terms of it fitted into the harmonic kind of palette of the piece. So what you're going to hear next is actually the original. So this is just to show you can steer, given a prime, you can steer it in many different ways. Okay, so getting to the last part, why would you want to steer it some way versus the other? So to test out how effective these tools are, we wanted to kind of situate users in a bit of a communication game. So imagine there's Alice and Bob, and Alice is trying to communicate kind of the imagery here that she's given. And to kind of compare if models are better or interfaces are better, she has, with two models, she each composes, kind of steers a small kind of music composition. And then she judges herself and says, okay, how effective do I think each of these models allow me to evoke the imagery and feel that I'm kind of had agency in actually making this happen. And then Bob listens to both of them and judges which one do I think is actually more musical and communicates the imagery more. So with this framework, we can evaluate both models. We can both kind of compare models by getting people to kind of pick which of the generations are more kind of reflect the imagery, or it could be an interface comparison. So in particular, the interface comparison here we have is this kind of tree-based versus like traditionally if you're just curating samples. So pretend you're a listener right now and listen to these two samples and think, which model do you feel was kind of a better tool for doing this? So in this case, the imagery that we wanted to communicate is this kind of more dreamy, kind of curious, things are mysterious and kind of just floating in the air. And the models we're comparing is Performance Arnon, the model that you heard in the very beginning, and this one is curated from Music Transformer. Okay, now we're going to compare the steering interface. And these are two more actively steered versions. And next you hear somebody else steering it in a slightly different way with given the same start. So in short, what we found in terms of this as a way to evaluate a model and interface improvements is that both of them were helpful in improving the composer's subjective empowerment, and also they also kind of improve the listener's objective kind of evaluation of how effective the music was. So to close, I wanted to kind of come back to this idea of a lot of times, if we want to build something that's useful for the user, we want to take this top-down approach. And at the same time, we also want to be able to situate in when the users are steering these controls, what are their higher level goals? And that means the way we're designing the interfaces, these are like where the users are doing the actions, allow us to kind of learn how these actions actually help the users achieve a higher level goal. So if you design the interface differently, you'll be able to observe the user's behavior on a different kind of sequence of events. So this really invites kind of this in tandem design of machine learning and HCI, so that you're thinking about both sides when you're designing both the interface and the learning to see how it can be more effective. So one example you can imagine is we have the steering interface. In some ways, this means the user's action is steering on this kind of higher level, more kind of compact chunk by chunk basis. And then instead of note by note, you have chunk by chunk to kind of get a sense of where the user is trying to go. And you can imagine fitting a model, kind of fine tuning it towards achieving these particular kinds of moods and user goals. Okay, yeah, so this is the end. I want to thank all my collaborators and also the organizers of the AI Song Contest. Thank you all for listening. I'll leave this up for questions.